Good morning guys. Today we have to see about the problem in DTS. Guys, the second unit spur gear drive. We have to solve the problem in spur gear drive. First sum, design a spur gear drive required to transmit 45 kilowatt at a pinion speed of 800 rpm. The velocity is 3:5:1. The teeth are 20 degree full depth in width with 18 teeth on the pinion. Both the pinion and gears are made up of steel with a maximum safe static stress of 180 Newton per mm square. Assume medium shock conditions. Here the spur gear drive is to transmit 45 kilowatt with the speed of 800 rpm. Here the velocity ratio is 3:5:1. We given it a power 45 kilowatt, N1 800 rpm, I equal to 3.5, pi equal to 20 degree. Number of teeth in pinion equal to 18. Then sigma B equal to 180 Newton per mm square. Since the pinion and gears are made of same steel, the pinion is the weaker, then we have to design the gear. First, selection of material. Both the steels are assumed as steel hardened to 200 BHM. Materials are safe. Steel, we have considered as a steel. Then calculation of Z1 and Z2, number of teeth. Assume Z1 as 18, then Z2 is equal to I into Z1, therefore 3.5 into 18 is 63. Then calculate the Ft, tangential force. The tangential force formula load by velocity into K0. Velocity pi dn by 60, pi into for diameter m into Z1 into n divided by 60 into 1000. Here the d1 is equal to m into Z1. M is m consider in mm. K0 medium shock, therefore Ft is equal to 74603 divided by meter. Then calculate the initial dynamic force. Dynamic force is equal to Ft divided by Cv. Here the velocity factor assumed as 12 meter per second. Then the formula in page data book 6 divided by 6 plus V for V greater than 20 meter per second. Therefore 0.33 value factor Cv value. Therefore Ft is equal to 74603 divided by m into 1 divided by 0.33, which is equal to 23809 divided by m. Then we have to find the forces, stress forces. Pi mb sigma b into y, b equal to 10m, y equal to y is a form factor from page data book for 20 degree full depth, y equal to 0.54 minus 0.912 divided by z1. Then calculations, we have find the value 0.1033. Fs is equal to pi into m into 10 mm into 180 into 0.1033. The final value is 583.15 meter square. Then calculation of models m. From the value Fs and Fd, which one is greater, we considered Fs is greater, Fs value from Fs value greater than or equal to 23809 divided by m. Then we solve this. M is equal to 7.26 mm. Then nearest standard value from PhD data book page number 8.2 is 8. Then calculation of B, D and V. Face with B is equal to 10 m, says 80 mm. Pitch circle dia D1 is equal to m into Z1, and pitch line velocity is equal to pi d n divided by 60, which is 6.03 meter per second. Then recommendation of beam strength Fs, the same formula, Fs is equal to pi m in B sigma y, then the value is 37885.45 Newton. Then calculation of dynamic load FD, the same formula available in page data book. Write the formula and put the values. We have the value 7.62.68 Newton. Then we have to check the beam strength. FD greater than Fs. So in order to reduce the dynamic load, FD, select precision gear as 0.019. Here the FD is 32920 Newton. So the design is safe. Then calculation of wear load FW, D1 into B into Q into KW. Here the Q is 2I divided by I plus 1. When we simplify it, we have the value 1.555. KW for 250 BHN is 0.919 for 20 degree full depth. FW is 16462 Newton. Then finally we have to solve the basic dimensions of pinion and the gear, which is available in page number in page in the book. The basic dimensions modules Z1 and Z2, diameters D1 and D2, and center distance A and the breadth. Thank you.